and Assalamualaikum. My name is Narelina binti Roslan. I'm a student of UniKl Miat, University Kuala Lumpur, Malaysian Institute of Aviation Technology. And today I would like to teach you subject Physics and Aerodynamic under a topic of optic light and sound wave. So I hope that you guys will understand what I'm going to teach you. And so let's get started. So this is our topic, optic light. This is a few subtopic under optic light. So from what I understand that light is a sound wave, electromagnetic wave that can be seen by a human. Light waves are part of electromagnetic wave or radiation that include X-ray, ultraviolet, infrared ray, and radio wave. So in free space, all electromagnetic waves have the velocity of light, which is you can see in my slide. So there are a few properties of light wave, such as it travels through space at the speed of light. It obeys the equation and carry energy from one place to another, and on absorptions cause a rise in temperature of the absorbing body. So this is the graph, a picture that going to make you guys understand better. So in light diffraction, firstly, within the light spectrum, there are 6 colors that can be readily identified, such as red, yellow, green, blue, violet, and which is indigo being difficult to distinguish. So, Sir Isaac Newton was the first person to explain this band of color known as the spectrum using glass prism. So, there are a picture that you guys got to see. Okay, when the light passes through from one medium to another, it is reflected or it changes angle. And white light passes through a prism, it is reflected twice, with red color reflected the least and violet light reflected the most. The separation of white color in this manner into the color of the spectrum is called dispersion. Dispersion of light through a glass prism. The picture will going to explain how it's going to work. So just as example that you can see. So the color combination is the object appear color because the surface will absorb some of the frequency and reflect others. A red violet, for example, will only allow light with a longer wavelength associated with the color red to pass through. Red, green, and blue are known as a light primary color as they cannot be created. So secondary color can be created by mixing two primary color. So this is the color. Reflection is the change in direction of a light wave when it bounces off a boundary. There are two laws of reflection. The incandescent ray, the reflected ray, and the normal to the surface of the mirror all lies in the same plane. The angle of reflection is equal to the angle of incandescence. Both angles are measured with respect to the normal to the mirror. This law of reflection applies equally to curve and a flat surface. There are two types of mirror. It's such a concave and a convex. So this is the picture. Concave and convex mirror. So a concave mirror is a surface that is shaped in towards the middle and away from the observer. A convex surface is a surface where the center is shaped out towards the observer in opposite direction to a concave surface. So this is an image formed by a concave and convex mirror. You can see the difference. So the point P is known as a pole and it's the center of a curved mirror. Point C is the center of curvature and is the center of the sphere of which is the curved mirror is part. Point F is called the principal focus and a focus point. Concave mirror rays are converged and convex mirror rays are diverged. You can see the difference in the picture that I show in my slide. So, a refraction. Refraction is a change in direction of the light ray occur when light ray move from one medium to another. This is called refraction. The direction of reflected. It depends on whether they are moved into more dense or less than medium and respectively slow down or speed up. So, observation on light reflection. The ray of light is bent towards the normal when it enters an optical lens medium of an edge. The ray of light is bent away from the normal as it enters an optically less dense medium. If the ray enters the block along the normal, it is not reflected. So, light reflective index. The reflection index N of a transparent medium is defined as the ratio of speed of light in vacuum to the speed of light in the medium. So, the formula is N equal to C over V, where the speed of light is C 300,000 km per second, and V is the speed of light in the desired medium. The reflection indices from water and glass are therefore. So the formula you can see, the example that you can see. So based on this definition, the reflection index of vacuum is 1 because you can see in the picture, if we divide the N and C, you can see it equal to 1. So air at a normal atmospheric pressure is very dilute and has a reflection index of 1, very close to that of a vacuum. So Snell law. Snell law is also known as the Snell discrete law and the law of reflection. Is a formula used to describe the relationship between the angle of incidence and refraction when referring to light or other wave passing through a boundary between two different isotopic media, such as water, glass, or air. The Snell law simply related angles I and R to the reflection indices of two media, N1 and N2. It is easy to show that N1 sin I and N2 sin R. Example, a ray of light that is making a 42 degrees angle which water surface enter water from air. Find the angle of refraction, that means the angle through which is enter water. Also find the angle of deviation. So this is the way that you can calculate. So these are the solution. You can see. So there are two basic lengths. We are going to talk about lengths. So there are two basic lengths, convex lengths and concave lengths. There are not too many different between mirror. So you can see F is known as the focal length. This value that our calculation of power is made of the formula power of a length. So this is the unit of power is type 3. You can see the formula from the picture. So this is the example you can see. So optic light condition. How an image appear. When using a lens can be obtained by drawing two of the following way. A ray parallel to the principal axis which is reflected through the focal point F. A ray through the optical center O, assuming no deviation caused by lens thickness. A ray through the focal point F which is reflected parallel to the principal axis. So where the image is positioned in nature, real and vertical can be found by using formula. So this is the example. So the next topic I'm going to teach is wave motion and sound. So mechanical wave. Energy can travel in two forms, either particle or wave. So a wave is a turbulence of a medium which transport energy. In a wave, particles of a medium are temporarily displaced and then return to their original position. The two most common forms is a transverse wave and a longitudinal wave. So a transverse wave. Firstly, the particles of medium are displaced in a direction of perpendicular to the direction of energy transport. The particles do not move along with the wave, they simply oscillate up and down. You can see the picture. So the longitudinal wave is the medium are displaced in a direction parallel to energy transport. The particles does not move down the tube with the wave. They are simply oscillate back and forth, move left to right. So you can see the transverse wave, it moves up and down, but the longitudinal wave is move left to right. So they're different. So water wave. Water wave are example of waves that involve a combination of both longitudinal and transverse waves. So it moves up and down and left to right. So this is the wave characteristic. Wavelength, the distance between the two crease, the frequency, the number of wave creases that pass a point every second, the amplitude, the height of the wave crease both the undisturbed position and the velocity, the speed of and direction that the wave crease itself is moving. So you can see back. So the wave characteristic, the relationship between wavelength, frequency and the velocity, we can see using the formula. See? And this is particularly useful for light. When the velocity is the speed of light, because then you have the relationship between the two. So the interference wave and standing wave. So interference or superposition occur at point where two or more waves meet. Two types of common interference is constructive interference and destructive interference. You can see the difference in the picture I've shown. So standing wave. Standing or stationary wave occur in wires that are tightly stretched between 2 points. You can see there are node and antinode. So sound. Sound is an energy and is produced when an object vibrates, causing the surrounding to vibrate also. Sound waves are also called acoustic waves, are region of high pressure and low pressure known as compression and refraction. The speed of sound is the distance traveled per unit time by a sound wave propagation through elastic medium. The SI unit of speed in the meter per second. In dry air at 220 degrees, the speed of sound is 343.2 meter per second. This is 1236 kilometer per hour. So speed of sound at sea level is 340.29 meter per second. So Doppler effect. The Doppler effect or Doppler shift is the change in frequency of a wave or other periodic event for an observer moving in relation to its source. So that's the end of my topic for today, and I hope you guys understand what I'm teaching. I'm sorry if there are some if you guys not understand what I'm talking about. So that's all for me, and thank you.